Okay, we're doing question 8 from the 2022 paper. Here we have a situation where we have a lot of text describing a diagram, and then we have the diagram itself. Okay, so what I want to say to you here is the picture tells the story. So there's no need to waste an awful lot of time in here. If we're not happy with the picture and we're not able to answer the question, we can go back and see that they throw in an extra piece of information that wasn't on the diagram. So now we're going to work out the size of angle C. So studying this, we have a right angle triangle, and so C and 35 degrees complete 90 degrees. It's the same as having them like this, 35 degrees and C, because together they add up to 90 degrees. And we understand that because in any triangle, the three angles add up to 180 degrees. So of course 180 degrees minus the 90 degrees that's down here as the right angle is 90 degrees. Okay, and the word that we use in geometry for two angles that add up to 90 is complementary. Okay, it comes from the word complete, complementary. So that's a palindrome there, E-M-E. It's just in terms of if you're learning to spell it, mentary. It's not with an I, which is a compliment, as in brilliant goal, well done, or you're looking great, that kind of thing. It's complementary in that they complete the 90 degrees. So complementary angles add to 90 degrees. And so C and 35 are complementary. And so C is equal to 90, take away 35, which is equal to 55 degrees. Okay, move on. By the way, there was extra information here because we were given the two sides of the right angle triangle, so we could have calculated C, and just curious to do that, it would use tan. So you do shift tan just to make sure that these measures all tally together and there isn't any problems. Inverse tan of 220 over 154. Okay, we're getting 55.008, which is close enough, and we'll go with their rounding. Okay, Mary works out that the horizontal distance between the buildings is 154 meters. Correct to the nearest meter as shown. Use the theorem of Pythagoras to work out the distance marked y on the diagram. Okay, so we have these two measures now and we're using them to calculate y. Okay, if you need to remind yourself of Pythagoras' theorem, it's on the bottom of page 16, and it relates to this triangle here. So don't be afraid to put that into your margins, A, B, and C. And it states that C squared equals A squared plus B squared. Or for us in this situation, it states that Y squared equals 220 squared plus 154 squared. Okay, so we can put that into our calculator. Now this is kind of going through it the long way if you like, and I'll do it the short way over here in a second. So we have 220 squared plus 154 squared. Okay, and we're writing down that square of y. And then of course we want to take the square root of this, so we will hit square root, and now it's very important that you push the word answer. Same on the older calculator as well. The answer might be in a different place, but it's all the same. Okay, and we get a third number, which we're going to write down because it's good practice too, and often they might want it in third form. But if we check then for what we call, and it's called a degree of accuracy. So once you get to this stage, you look for what degree of accuracy and what way. Do they want the exact answer where it would look like this, or do they want it rounded where it would look like a decimal? So in this case, the distance marked y, give your answer correct to the nearest meter. So first now I need to see what's called a digital expansion. of this exact number. Okay, and for that I'm going to hit Shift equals. You can also format it as a decimal, but it takes a bit longer, and you get 16.387, and I'll truncate there, and then I'll worry about the rest of it, which is rounding. And because I'm rounding to the nearest meter, this is my rounding zone here. Okay, and I'm not going up, so that can't be right. I've obviously done square root twice or something. Yeah, because every time I square root it. Okay, so which brings me across to here. So if I did it a quick way, which would be do the square root before you square these. So you say, well, I don't want y squared, I want y. So you'd be square rooting here. Or indeed, from up here and from this, you'd be saying, look, I know that if I want the hypotenuse, it's the square root of this. It's the square root of the sum of the other two squares. So this can be your starting point from page 16, or from your Pythagoras when you're getting a hypotenuse. Okay, so we're rounding up, and so it's 269 meters.